So today we're talking about adding and subtracting radicals, and basically you can only add or subtract radicals if they have the same number under the radical. The number underneath the radical is called the radicand. Just throwing some vocab at you. So let's do some examples. Let's do like number 1, right? Suppose you have radical 2 plus radical 2. How many radical 2's do you have? Oh, that's 2 radical 2, right? Because there's like a 1 in, you have one of each of them. If ever you don't see a number. This is the same thing, if you want to think of it, as me saying this. What's x plus x? No. 2x. But instead of x's, I'm using radicals. Oh, got it? Let's play again. How about 2? Let's do 3 radical 2 plus 4 radical 2. How much is that? Yeah, this is 7 radical 2 because it's the same thing as me saying 3x plus 4x equals 7x. It's the same thing. It's the same thing. Oh, what's up? Yeah, variables just hold the place for numbers, and if you have the same number being subbed into a particular spot, you use the same letter, like x's. If it's a different number, you use a different letter, like y's. All right, let's step our game up a notch. Stepping it up. How about if we have 3 radical 2 plus 2 radical 3? Now, I know that's confusing to you. Can you add those together? Why not? The radicals are not the same. That's how it works. And if you're to say, what does this equal? It equals itself. 3 radical 2 plus 2 radical 3. That's how you leave it. You don't add any of the numbers in the front. You don't do anything with it. You just leave it alone. You want to think of it another way? This is like 3x plus 4y. 3x plus 4y is 3x plus 4y. They are not like terms. Right? And hopefully maybe somebody's going to do one of their bonus projects about adding or about combining like terms or solving equations so people can see that, because they always mess that up. The radicals cannot be, oh, let's talk about that. That's a good question. So let's do 4. Suppose now we have like 2 radical 5 minus 8 radical 5. How much do I have? Negative 6, what? I have negative 6 radical 5s. That's like 2x minus 8x. It's negative 6x. You know what I'm saying? Yeah? Good. We got one more example to do, and then we're going to work on those top problems, and then I'm going to give you your homework. Easy day. Let's do 5. Let's do 5. Uh-oh. Suppose you have the square root of 25, and you want to add to it the square root of 75. How do you do that? Now you're saying to yourself, you say to yourself, self, these are not the same, right? So normally you would leave it like that, but here's the trick. Can you break these down? If you can break them down, sometimes it's kind of hidden whether you could add or subtract them. It's only when things are broken down into their simplest form that you can really truly tell. So let's simplify them. Let me use a different color. What's the square root of 25? What should I break it up into? Oh, look at that. I messed up. The square root of 25 is 5. The square root of 75 is 25 times 3. And that's going to be 5 plus 5 radical 3. Right. Now you say to yourself, self, what do I do with those 5s in front? Do I have 10 radical 3s? No, I only have 5 of them, plus 5 more of something else. That is your final answer. That's how you leave it. Right? That's how you leave it. That's in its most simplified form. One more, one more, one more, one. No, I'm just kidding. We got 3 more. Okay. Let's go with the square root of 3 minus the square root of 12. Can you do that? You can? Because you can simplify the square root of 12, right? The square root of 12 is radical 4 times radical 3. This is going to be rad 3 minus 2 radical 3. And if I have 1 radical 3 and I subtract 2 away from it, how many radical 3s am I left with? Negative 1 square root of 3. What? What happened? What? Is that hard? No, come on. Let me talk about this. Let's go back to we have questions about number 5. Alondra, this bottom step over here, right? That's like the same thing as me saying 5 plus 5x, right? If you have 5 plus 5x, is that 10x? No, you literally don't have 10 x's. You have 5. 1, 2, 3, 4, 5, and then you have 5 more x's. So it's the same thing with radicals. If you don't like dealing with the radicals, you can use letters to like move them around and add and subtract them. But at the end, when you get your answer, you're going to have to sub the numbers back in, okay? So who else? Any other questions? Preguntas, por favor? Steven? Yeah? Technically, when I say the word radical, it only refers to this weird-looking wrapper that I keep saying. You know that little square root symbol? That's a radical symbol, right? So the word radical means the symbol. The radicand is the number underneath the symbol. Yeah? It's like candy in a wrapper, radicandy, you know? In the wrapper of the radical. No? You don't think of it that way? These problems are amazing. They're so sweet. You could just eat so much of them, do so many of them, and never get tired. Okay, let's do 7. We got 2 more, and then I'm gonna give you your homework, and then we're out of here. Okay, all right. How about this one? Let's do something. 8 rad 5 plus rad 5 minus 2 rad 5. Ay, 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 Dios mío. What? Okay. Okay. Let's see. 9 minus 2. Yes, Raph, you are the freaking man. You are the freaking man. Okay, last one, last one, last one, last one. Let's do this. 5 rad 3 plus 4. Let's break down 12. Who knows what 12 could break up into? Nacho. 4 and 3, 4 and 3. So here we go. We got 5 rad 3 plus 4 times 2 rad 3. What's up? Who, me? And that's going to be 13 rad 3.